While we have mentioned that the Bernoulli's equation is extremely important in engineering applications, in everyday applications, and in our practical life, they are very useful. But at the same time, when we are considering a fluid flow and applying the Bernoulli equation, we must remember and keep in our mind the limitation that it has. And limitations are the assumptions that we made when deriving this equation. We go over them again here and discuss a little or remind ourselves that this is important to remember these points whenever we are discussing Bernoulli's equation or applying it to a fluid flow situation. It's important to know that the Bernoulli's equation is valid for steady flow. Normally, it is valid for steady flow, and unsteady flow, we have to make modifications. The fluid flow is considered to be frictionless, that is, it is inviscid, and no heat is generated. So, although in reality, every flow involves some friction, but when we say it is frictionless, we mean to say that the friction is so small compared to the other forces that are occurring, that those forces are dominating and they are much bigger as compared to the frictional forces, and therefore frictional forces can be easily taken to be zero or can be ignored, and therefore they are taken to be as if they are not existing. No pumps or turbines are involved. No fan is there. So all the fluid flow is taking place along a streamline. When the devices like turbines, fans, etc. do exist, however, when they do come into play, then the energy equation should be used instead, that is, instead of the Bernoulli's equation. Incompressible flow, the incompressibility is also important. That's another limitation of the application of Bernoulli equation. That Bernoulli equation requires that the fluid must be inviscid, incompressible. And of course, most liquids are incompressible. For example, like water. If we are considering a flow of water in a channel, in a canal, in a river, or in any channel that is under consideration, then that is considered to be incompressible. Most liquid come into that category, and of course, gases is one example where their density changes when the forces are applied. The flow is incompressible for liquids and also gases at Mach numbers that are less than 0.3. And we also assume that no heat transfer is taking place. So that we have already mentioned, because if there is a heat transfer taking place, then we have to consider a proper full energy equation. Bernoulli equation will not be valid in that case. The flow is always along streamline, and strictly speaking, Bernoulli equation is only applicable to that situation, that is, along a straight line, along a streamline. It's very important. However, when the region of flow is irrotational and there is negligibly a small vorticity, that is, they are referring to that the flow should be irrotational, then Bernoulli equation becomes applicable across all streamlines. Here are some examples of showing the limitations of the Bernoulli's equation and where it can be applied. The pictures that are shown on the left hand side, we are having problems there, different situation, there is fan, there is heating, they are not valid here. But on the right hand side you can see that along the streamlines the equation is valid at point 1 and point 2. It will be the same values that it will occur, that is, this equation will be constant. And here again, this is evolve. So when evolve is applied, and again then there is a limitation of Bernoulli's equation that we cannot really apply it because the pressure will be changing and a different situation occurs. And again, where there is boundary layer, we will not be able to apply Bernoulli equation there, because boundary layer occur, or the presence of boundary layer means that viscous effects are there. And when we are deriving Bernoulli's equation, Bernoulli equation is derived on the assumption that it is for inviscid fluid. So frictional effects, heat transfer, and components that disturb the streamline structure of flow make the Bernoulli equation invalid. So remember these points, and basically these points we are discussing and we are pointing out the limitations of Bernoulli equation. And by saying this, we mean that there are places, there are fluid flows where we can apply it, there are places where we cannot apply. But still, its equation is so important that it is applied in a large number of cases.